Hey guys, here's your guys' notes on the rational root theorem, introduction, okay? So students will be able to use the rational root theorem to find the root zeros of a polynomial function. So in order to do that, you guys, we first have to make this thing called a P over Q list. So if P over Q is in simplest form and is a rational root of a polynomial equation having integer coefficients, then the P must be a factor of the constant term, and your guys' Q must be a factor of the leading coefficient. So you guys have to make a factor of P with your guys' leading Q for your leading coefficient. So here we have a P over Q list where P is your guys' factors of your constant and Q is the factors of your guys' leading coefficient. One clever way to remember that Q is in the front and P is in the back is the phrase cutie pie. If you guys remember cutie pie, Q becomes before the P for cutie pie, okay? So for number 1, we have a coefficient of 1 for the front and a -2 constant term. So this is your guys' P and that's your guys' Q. Find your factors of Q, which is 1 and 1, factors of -2, which is 1 and which is 2. So you find your factors of P, which is -2, and your guys' factors of Q, which is 1. So our factors of P is plus and minus 1, plus and minus 2. The reason why it's plus or minus, you guys, is because 1 times -2 is -2, -1 times +2 is also -2. Factors of Q is just plus or minus 1, because 1 times 1 is +1, or -1 times -1 is +1. So to find all your guys' possible rational zeros, you just divide these by the 1 at the bottom. 1 divided by 1, plus or minus 1. 2 divided by 1, plus or minus 2. Now number 2. So we have factors of, we gotta find our P and our Q. So our factors of P, you guys, I'll write it over here. So factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And your guys' factors of Q is 1 and 3. So find factors of 12, which was 1 plus and minus 1, 2, 3, 4, 6, and 12. And your factors of Q, which is factors of 3, plus or minus 1, plus or minus 3. So we have to divide all these by these to find our possible rational zeros. These aren't our zeros, you guys. These are possible answers. So divide all of these by 1, you guys. So plus or minus 1, 2, 3, 4, 6, and 12. Divide all of these, you guys, by 3. Now let's see which ones will give us new answers, right? 1 over 3, 1/3. 2 over 3, 2/3. 3 over 3, you guys, is 1, which is already in our list. 4 over 3, that's a new one. 4/3. We're not going to do 6 over 3, guys, because that's 2. That's already in our list. And we're not going to do 12 divided by 3 either, because that's 4. So these are all the possible zeros of our function. Possible, so some of them could be our answers, none of them, or all of them. Actually, it can't technically be all because there's only 4 answers. Anyways, number 3. Here's P, there's Q. Find your guys' factors of P, which is 1 times 10, 2 times 5. Factors of Q, 1 times 2. So make your guys' P over Q list. Factors of P, plus and minus 1, 2, 5, and 10. Factors of Q, 1 times 2. So divide all of these, you guys, by 1, which is plus and minus 1, 2, 5, and 10. Take all these numbers, you guys, and divide by 2. Well, the only one that, or there's 2 of them, 1/2 would give you guys a new number. You can't do 2 over 2 because 2 over 2, you guys, is just 1, which is already in our list. 5 over 2 is a new number. And 10 over 2 is not because that's just 5. So those would be your guys' answer for possible rational zeros. Now, here is a brief introduction on how we can find our zeros now that we know that list. So find P over Q, figure out which one of these possible rational zeros is a factor of your polynomial by using synthetic division, then keep using synthetic division until your polynomial gets to a degree of 2, then solve your zeros by factoring. So for example, we're finding all of our zeros, so we're trying to figure out what x is equals to. That's P, that's Q, factors of P, 1, 8, 2, 4, factors of Q, 1, and 1. So when you guys make your possible rational zeros list, P over Q, factors of P is plus and minus 1, 2, 4, and 8, and plus and minus 1. All those divided by 1, you guys, is plus and minus 1, 2, 4, and 8. So these are our possible rational zeros. These are our possible rational zeros, you guys, which means some of these could be our answer, none or all. To test to see if it is, you guys have to guess and check using these and use synthetic division to see if you guys get a remainder of 0. Because if it's a remainder of 0, that means that's a 0 and it will be one of your guys' factors. So for example, if you guys try to plug in 1 into this, right? So let's say you guys think 1 is possible 0. Write down the coefficients, 1, 3, negative 6, and negative 8. 1 times 1 is 1, add 4, 4 times 1 is 4, add negative 2 times 1 is negative 2, add, you guys get negative 10. So this did not give us a remainder of 0, which means 1 is not going to be a 0 to our answer, which means you gotta try again, right? And you guys keep on trying until you do find 1, because if you do find 1, then we can use synthetic division to decrease that degree to a degree of 2 and then factor. So let's try 2. So if we try 2, you guys, 1, 3, negative 6, and negative 8. 1 times 2 is 2, add 5, 5 times 2 is 10, add, we get 4, 4 times 2 is 8. So we found a 0, right? So this is one of our answers, and it's going to be a factor. So look at your guys' highest degree, which is 3. So this is going to be x to the second, x. So that means we have x squared plus 5x plus 4, you guys. And in order to solve for this, we do factoring using your guys' x method. And we're going to get x plus 4 times x plus 1 equals 0. X equals negative 4, and x is equals to negative 1. So our answer is going to be 2, because that's our first 0 we guessed, negative 4, and negative 1. So just a brief introduction. We didn't go over this one, you guys, but this is a brief introduction to how you guys can find your zeros using rational root theorem, okay? Make sure you scale that, you guys, from 1 through 5, and do your guys' exit ticket summary, okay? Good luck, you guys. Practice your P's over Q's for your homework assignment, and the more you guys practice this, the better this does become, okay? Good luck, you guys. Peace.